Okay, I wanted to touch on something that's important, and that has to do with actually evaluating these integrals, getting values. So we've worked on representing these quantities, these values with integrals, but let's actually get some numbers so we can get a feel for the fact that they truly are representing numbers, and we want to know how to get those values. Okay, so we came up with this function. We have this rate function for the temperature inside the fridge and for these 15 minutes, and this is our rate function. And so in class we came up with a function that gives the exact temperature in the fridge over this 15-minute period. So that function will be, we can call the temperature function. So we'll say t of x, and we already did this. The starting temperature at time equals 0 is 40. That was given. And then after x minutes, the temperature will be 0 to x, r, and then we need to have some different value, so we could use u. So ru du, where r is the rate function. Okay, so suppose we wanted to say, so what would the meaning of t of 10 be? So you should know what that is referring to, t of 10. Well, that would be at 10 minutes. This would give us the temperature in the fridge 10 minutes after this starting value of time, where we knew it was 40. So t of 10 then would be 40 plus 0 to 10 of ru du. So we do not have kind of an algebraic method of solving this by hand. So as far as we know right now, in terms of what we have, we can use graphing calculator to do it. So I'm going to come over here, and I want to solve 40 plus integral, which is Control-Shift-I. We're going to go from 0 to 10 of, and I can just type in Rx, use Control-9 for functions, and I want to change this. I want to do du, and when I do this, I should get a number. So it just pops up. And what is that telling us? It's telling us that this is 40 plus the value of the integral was 2.8167 degrees, meaning that the change in temperature from 0 minutes to 10 minutes at this rate was a positive 2.1867. Adds to the 40, gives us the temperature in the fridge at 10 minutes. Okay, so this value, t of 10, is 42.8 approximately degrees Fahrenheit. Okay, so graphing calculator can do this evaluation for you, and so on your homework you have some to do. You're going to use graphing calculator to get the values of these integrals, which gives the value of an integral gives a net change in the quantity, right? The change of temperature from, in this case, from 0 to 10. Okay, so then similarly, asked to write expression the two ways that gives the greatest total increase in temperature. And the greatest total increase in temperature will be from when it starts increasing to when it stops increasing, right? So through this whole portion of the graph, the rate is positive, so the temperature is increasing through this whole thing. So instead of estimating this to be 4 and 13, let's get these exact values so we can get the exact. So I'm going to come over here, and I'm going to find that it's actually 3.8. We'll go with we'll go 3.8. Okay, so this is 3.8 minutes when it starts, the rate becomes positive and the temperature starts to increase, and then at, when does it finish increasing? Right here at 13.2. minutes is when the rate changes from positive to negative. Therefore, the temperature no longer stops increasing and begins to decrease. Okay, so see if you can, so pause right here and see if you can use Graphing Calculator to find that change in temperature, that increase in temperature from 3.8 minutes to 13.2 minutes. See if you can get that value using Graphing Calculator. And then unpause it, and I will show you how to do it. Okay, so here we go. We're going to do, to get that change in temperature from 3.8 minutes to 13.2 minutes, I'm going to do the integral. So Control-Shift-I. We're going to go from 3.8 to 13.2, and that's going to be for R, Control-9U. And as soon as I hit this DU, I'm going to get a number. And there it is. It was a 6.07 temperature increase from the greatest increase over this 15 minutes, from when it started to increase to when it stopped increasing at those times. So that would be represented over here by, so that's the value of that integral. This down again, that's coming over here. That's an expression that gives the greatest total increase in temperature over the 15 minutes. And so looking at the actual temperature graph, we could also confirm that by coming down here to 3.8. Okay, that's the best I can do right there. And we get a Y of 38.5207. So at the coolest point, it was 38.52 degrees, up to when it stopped decreasing, and we said that was at 13.2, so as close as I can, that's about as close as I can get. And that's 44.59. So this right here can represent that change in temperature, that greatest amount of increase over this 15-minute period, right from there to there. And we should get something very close to 6.06 if we take 44.59 minus 38.52. So let's do that. 44.59 minus 38.52. There it is, 6.0. It's almost the same. 6.068 versus 6.07. Okay, so my biggest reason was to show you how Graphing Calculator can solve these integrals. And these integrals represent numbers, they're values, and that's why we've been emphasizing their meaning. In this case, it's the net change in temperature, starting at 3.8 minutes and ending at 13.2 minutes. This is a positive value, meaning the temperature went up 6.07 degrees Fahrenheit. Hope that helps you with the My Math Lab homework. Okay, see you on Friday.